Hello, everybody. I hope you're all doing well. Welcome to this session of Enlightening Math, and today we'll be covering pre-algebra, the Pythagorean theorem. Let's dive right in. So, first off, what is the Pythagorean theorem? In a right triangle with legs A and legs B, and the hypotenuse, which is leg C, uh, the hypotenuse is the side that is opposite to the right triangle. The Pythagorean theorem states that a squared plus b squared is equal to c squared. As distance is non-negative, c is always the longest side. One example of this is if a is equal to 3 and b is equal to 4, then c is equal to square root 3 squared plus 4 squared, or 5. Now, keep in mind that this is only possible in right triangles. You cannot use the Pythagorean theorem in any other triangle. So, the geometric meaning of this is the areas of the squares on the legs add up to the area of the square on the hypotenuse. Area on A plus area on B is equal to the area on C. Once again, this only holds for right triangles, not acute or obtuse ones. So now, to solve for a missing side in the triangle, we have C is equal to square root A squared plus B squared. This is just another formula that we can derive from the original Pythagorean theorem. So as we see here we have A squared plus B squared is equal to C squared, which then becomes C is equal to square root A squared plus B squared when we just move around a few things. So that can also be A is equal to square root C squared minus B squared, or B is equal to square root C squared minus A squared. So an example of this is if we have sides A and sides B, and A is 6 and B is 8, C is equal to square root 36 plus 64, or square root 100. Therefore, C is equal to 10. Now, another example, we have side B given as 9, and side C given as 15. In this case, we have A is equal to square root 225, or 15 squared, minus 81, or 9 squared, which is equal to square root 144, or 12. Now, just so you guys really understand how the triangle looks in a situation like this, I'll draw one out for you. So we have a triangle here. It is a right triangle, as always in a Pythagorean theorem situation. And then we have side A, B, and C. Now, keep in mind, once again, Pythagorean theorem only applicable to right triangles. So next up, we have Pythagorean triples. So Pythagorean triples are common integer solutions to the Pythagorean theorem, or a squared plus b squared is c squared. So some examples of this are 3, 4, 5 triangles, which would be where a is 3, b is 4, and c is 5. 5, 12, 13 triangles where a is 5, b is 12, and c is 13. 7, 24, 25 triangles, 8, 15, 17 triangles, 9, 40, 41 triangles. When you scale a Pythagorean triple, it yields another triple. For example, we have triple 3, 4, 5. Multiply all numbers by 2, we have triple 6, 8, 10. So these are just common Pythagorean situations, basically, where you see the numerical integers in the triangle and you put them into the formula and you find all the sides. These are the most common sides that we use. So applications of the Pythagorean theorem, checking right angles when you have all the other sides. If you have all sides and you know it's a Pythagorean triple, then you know that it is a right angle, that one of the angles. Mapping straight line distances or displacement, which is a subject that you'll learn later on. And then designing, once again, it's similar to distance. So we have an example here, the ladder. If the bottom of the ladder is 5 feet from a wall, the top reaches 12 feet high, then what is C? So we have 5 squared plus 12 squared is equal to square root 169, which is equal to 13. This tells us that the ladder itself is 13 feet. We also did not actually have to solve this if you have your Pythagorean triples memorized. That is listed as one of the first common Pythagorean triples. Here we have a word problem example. A TV is 60 inches diagonally and 40 inches wide. Height h satisfies 48 squared plus h squared is equal to 60 squared. H squared is therefore equal to 1,296. Therefore, the height is 36 inches. Another example of this would be in a garden, where we know the garden is a 9 by 12 rectangle with a diagonal across it. To find that diagonal, we do square root 9 squared plus 12 squared, which is just 15 meters in this scenario. So some common mistakes, using a squared plus b squared equals c squared, or the Pythagorean theorem, when the angle across from the hypotenuse is not 90 degrees, forgetting that side C must be the hypotenuse, and taking the square root too early before you fully solve for a squared plus b squared. Now, we can also do the converse of this, where if a triangle with sides A, B, and C satisfies a squared plus b squared is c squared, or is a Pythagorean triple, then angle opposite C is a right triangle. For example, 9 squared plus 12 squared is equal to 81 plus 144, which is 225, or 15 squared. Therefore, that triangle is a right triangle. This will not be used currently, but later on, when you guys learn triangle proofs, it'll be very important. It can also be used in distance in planes, which is once again not a subject that you'll learn now. So we'll go over this, but this formula for distance in a plane is based off the Pythagorean theorem. So we have a real world example here. An aircraft climbs 300 feet while traveling and moves 4,000 feet horizontally. The straight line distance from the start is d, or distance, which is square root 3,000 squared plus 4,000 squared, which is just 5,000 feet. Here we have some quick practice problems. You can go ahead and screenshot these if you would like. And now some key takeaways before we finish up. So once again, the Pythagorean theorem only applies to right triangles. Hypotenuse is always opposite to the right triangle. And you can use the converse to test for right triangles. Thank you guys for your time, and I hope you have a good rest of your day.